Assalamualaikum. So today I'm going to show you how to simulate a circuit and deduce the Thevenin equivalent using Pspice. Okay, the circuit that we are going to construct is this circuit, and we would like to know the Thevenin equivalent at terminal A and D. Okay, so we know that Thevenin equivalent is VTH, RTH, right? And we know that in order to measure the VTH, it is the open circuit voltage between the terminals A and D. And to measure RTH, you have to turn off the power supply and then measure the resistance. So that is your RTH. Okay, so this is your circuit, and I have opened the Orcad capture Pspice. I am going to construct the circuit. So you go to the analog library and find resistor. So I am going to add 5 resistors because there are 5 resistors in the circuit. Okay, so R1 is 3.6 kilo ohm. Okay, R2 is 1.5. R3 is 1 kilo ohm. R4 is 0.330 kilo ohm, and R5 is 2.7. Okay, 2.7 kilo ohm. Okay, so 2.7 is vertical, so I'm just going to press R to rotate it, and similar to R4. Okay, 3.6 is horizontal, 1K is horizontal, and similarly your R2. Okay, so the next thing is the power supply, which is from the source library. So I will go to source and find VDC. Okay, so it's connected there, and the value is 10 volt. Okay, right. So now I am going to connect the parts using wire. Okay, so it's easier if you use mouse, right? Just click and you will be able to connect all the components. Okay, so this one will go here, and this is my node A. All right, and this is my node D. Okay, but don't forget your ground. So ground, I will use the library capsim. Okay, so it'll be 0 volt there, and don't forget to connect to the whole circuit. Okay, so yeah, this is my circuit ready to simulate. Okay, so next is creating my new simulation profile. So I'm going to call it Thevenin 2. Okay, just a name, it doesn't matter. All right, and because it's not a time-based output, so I'm just going to click OK for this. Right, so now I want to see what is the voltage, right? The voltage between A and D. Okay, so if I click run and then press this volt button, okay, I will see the voltage at this point, but I will not know the voltage here. The voltage here is, yeah, 2.6. It's the same node, right? Let me remove the current. So my voltage here is 2.697, okay, which is the same as this node. And this reference is 0 volt. So between A and D, 2.697 minus 0 is 2.697 volt. So that will be my VTH. Okay. So if I look at the answer, it is 2.7. Okay. So the answer is 2.7 volt. Next is how to measure the Thevenin resistance. So I'm going to turn this off first. All right. And you can close this off as well. So now the first thing you need to do is you need to turn off the power supply. You need to short circuit, right? So you have to short circuit it to ground. So that's what I'm doing here. You can see that. So how to measure the resistance is you can add a VDC, okay, at the terminal, and just make it as 1 volt. Okay, 1 volt. And this is like your test current and test voltage, Vx, Ix. So, but I give a value 1 volt so that whatever current there, whatever current flowing through this, it will be 1 over the current here, and that will be your RTH. Okay, so let's see whether it works. Let me save the file first, and then I'm going to run it and show the current. Okay, so we want the current over here. So if I calculate it correctly, 1 divided by 882.3 to the power of minus 6, I will get 1133 ohm, which is 1.13 kilo ohm. Okay, so I've done the experiment and that is the answer, 1.13 kilo ohm. Okay, so yeah, that's how you can measure the RTH for your Thevenin circuit. But don't forget, you need to turn off the power supply. Okay? So next, what if we would like to place a load resistor? In this case, RL equivalent to 150 ohm between terminal A and D. So firstly, you need to turn the supply back on before you place the resistor. Okay? So that is what I'm going to do. So I'm going to remove this test voltage. Okay? And I'm going to bring back my 10 volt supply. Okay, let me connect everything correctly. Okay, so I need to add my RL. Okay. Okay, so this is my RL. Let me just put the name RL. And this is 150 ohm. Okay. Right. So now I'm going to save it and run the simulation again. Let me show the current and the voltage. Okay. So the current through RL is 2.1 milliampere. Yeah. And the voltage here at this node, which is the same as this node, is 315 millivolt. Okay. Which is what I have obtained, 0.315 volt, and the current through RL is 2.1 milliampere as shown in this Pspice. Okay, so basically by the simulation we have proven the experiment is correct. Okay, so what I want to show to you now is proving that the Thevenin equivalent with terminal AD connected with RL will also give the same current. So let me put another circuit down below here. I'm going to put another resistor, which is going to be as RTH. I'm going to name this RTH. Okay. And then let me put another power supply as VTH. Okay, I'm going to call this VTH. Okay. And I'm going to connect this. Okay. So this is my Thevenin equivalent, right? And just now we obtain our RTH as 1.13 kilo ohm, 1.13 K. And my VTH is 2.7 volt. Okay. So next I'm going to add another resistor representing RL. I'm going to call this RL2 because I do not want to have the same name as this RL. Okay. So now I am going to connect them, and don't forget the ground. Okay. Okay, change the value to 150 ohm. And now I'm going to run the circuit. And you can see here that the current is 2.10 milliampere. Okay, plus minus because I have rounded up my RTH. Okay, similarly, I have also rounded up my VTH, right? Next is the voltage. So yeah, 316 millivolt versus 315 millivolt. Again, there are some plus minus due to rounding up of the values. But this clearly shows that the Thevenin theorem valid. For this circuit, it shows that when you add a load resistor, you will get the same current and voltage. So that's the end of the experiment and the simulation session. Thank you.